Hi, my name is Łukasz Rozmain, and I'm from Nethermind team. I am working on core Ethereum 1 development. Recently, I implemented Rionism merge spec 0.1.2 in Nethermind client. Rionism is the name chosen for merging Ethereum 1 and Ethereum 2 beacon chain into just one Ethereum. For anyone interested in the specs, internals, it will be linked in the video below. As you can see on my screen, there is an Ethereum Rionism repository, and here you can find merge spec. You can view it later if you're interested. Today, I want to show you a glimpse into Ethereum future. We will set up Ethereum 2 and Ethereum 1 nodes and compare them, creating a post-merge node. You can later play with it and even use it for testing of any products that you are developing that target post-merge ecosystem. You can also use it to participate in scaling Ethereum Hackathon DevNets. More information on that later. Firstly, a small disclaimer. This tutorial is based on ProtoLambda's written version, to which I contributed instructions about how to run Nethermind. So big thanks to him and all the other teams that contributed there. You can find this tutorial at the link below. It's also available from the Rionism repository. You can find it at the Mergent tutorial. Let's click it. I am recording it on the 27th of April. Please note that there are some planned changes to the written version of the tutorial to make it more accessible and combine some steps into bigger scripts. If you are watching this later, the process might have changed slightly. As for today, there are instructions on how to run clients that are ready to test the merge. For Ethereum 1 side, it's Nethermind and Geth, here in the tutorial called Catalyst. For Ethereum 2, it's Teku, Lighthouse, and Prism. Please note that Prism instructions are still in pull request, so please check if you can't find it in the master version. As Ethereum Merge will open a new chapter in Ethereum history, I encourage you to experiment with different clients from both Ethereum 1 and Ethereum 2 sides, and pick ones that suit your needs best. Please note that client diversity is a big strength of the Ethereum ecosystem that allows us to get where it is now. Here in this tutorial, we will be using Nethermind for Ethereum 1 client and Teku for Ethereum 2 client. But most of this tutorial can be also used with other clients. Just swap the relevant client-specific commands for other ones from the written tutorial. Similarly, we will use Docker for simplicity and convenience of installing and running clients. You can use native packages if they are supported on your operating system, but in order to simplify our setup, we'll use Docker. As our environment, we'll use a Linux virtual machine, but thanks to Docker abstraction, this should easily translate to other operating systems, and I was even able to run this on Windows. So let's go to our virtual machine. Let's see what distribution is it running, as this might be helpful for you to understand why certain commands work here and might not work on your distribution. As you can see, it's recent Ubuntu distribution. Now let's look at the tutorial. First thing that we need to do is to clone the tutorial with Git to our virtual machine. Let's check if there is a Git installed. As you see, there is a Git installed, but if you don't have Git installed on your machine, you can easily install it like this. Or if you're running different operating system or different distribution, please check how to install Git on that. For example, for Windows, most installations will be by downloading some installer and running it. So let's clone the Mergenet tutorial repository. Okay, the Mergent tutorial repository is cloned. Let's change directory into it. Okay, now let's check what's next in the tutorial. As you see, we need Python and Go version 1.16 and upper. So let's check if that is installed, and if not, install that. To check Python version, we can run python -v. It says Python not found, but actually there is a Python version called Python 3 here. It's Python 3.8.5. If you don't have Python, you can install it. How to install it depends on your operating system again. You can check into this link, and it shows you some instructions how to install Python for different operating systems. Let's alias Python 3 to Python, as that's how most of the tutorial instructions are written. Now we can see that Python version works well. Now we need to check if Go is installed. To check that, run Go version. It's not installed here. As you can see, we can install it with snap or apt, but apt only gives us version 1.13 while we need version 1.16, so we will use snap. Let's use sudo snap install go ---- classic. It will download Go and install. If you need directions how to install Go on your operating system, you can go to the Golang doc about installation, and you will find here instructions how to install the Linux Max on Windows. Now, when it is installed, we can check the Go version, and it says it's 1.16.3. That's good. What we need to also do is export the Go path environment variable. So let's set it here, and let's add it into the path environment variable. Okay, now we're done. Now we need to check if Docker is installed. Let's write docker -v. No, it's not installed. So let's install it with apt install docker.io. Agree to everything. It will take a minute to download and install Docker. Once Docker is installed, we need to check if we have pip, which is Python installer. Python -m pip ---- version. We don't have a module called pip, so let's install it here. apt install python 3 -pip. This will allow us to install Python packages, or modules actually. This will allow us to install Python modules. It might take a minute to install. There are two packages that are later used in scripts. We need web3, so we write python -m pip install web3. Again, it will take a minute to install. As you can see, the tutorial wants us to install virtual environment for Python, but as I'm using a disposable virtual machine, I don't want to work in virtual environment, and I prefer working directly. Let's install the second package, which is MergenetYamu. Python -m pip install MergenetYamu. Okay, when it's installed, we can go back to the tutorial and go through its later parts. Firstly, we need to install two tools that are created by ProtoLambda. So let's do this. Let's install first of the tool. It will take a minute. Those tools will be later used for generating configuration files and Ethereum 2 setup. Okay, it finished. This is the second of the tool. Okay, both tools are installed. Now comes the tricky part. Before we actually will be able to run anything, and even before we can generate configurations files for our setup, we need to firstly modify MergenetYamu file. This is explained here. Why we need to do this? So firstly, before we go there, let's grab a current date time. This is current date and time in Linux system as a timestamp, which is number of seconds since epoch. Let's grab it somewhere, and then let's go to the MergenetYamu file. This file will be base for generating other files that will orchestrate how the clients will operate. But before we do that, let's grab the current time. Using this command, we get a Linux timestamp. This is actually current time in some simple format with accuracy up to seconds. To open the file, I will use nano, but you can use other text editors of your choice like VI or Vim. Nano is pre-installed on the boot too. Here we want to change it, so let's open Mergent. Here we are actually interested in two things: ET1 Genesis timestamp and ETH Genesis delay. So the grab timestamp we grabbed a second ago, we'll paste here. And we have 600 seconds delay. That means that 600 seconds from now, our ETH2 client will think that Genesis happened and will start communicating with our ETH1 client. So we have a 10-minute window to set up everything properly. Let's save the file with Ctrl O, enter, and Ctrl X to exit. Let's check with cat if the file was saved properly. Looks like it. Now let's create a testnet name environment variable with the name of our testnet. Let's call it my network. Then we need to create some directories for the testnet. Directory for the testnet. Directory for some public information of the testnet. Directory for some private information of the testnet. Lastly, we will use templates and Python to create configuration files for our clients using previously configured MergenetYamu. Nethermind uses different chain genesis file, so we need to both generate the standard genesis file and Nethermind's. Firstly, we'll generate the Geth-like Ethereum 1 configuration. Secondly, we will generate configuration for Ethereum 2 client. And lastly, we'll generate configuration for Nethermind. If you scroll down, we can have the command here. Now we need to prepare Ethereum 2 data using previously installed Go modules. Firstly, let's create a Genesis file in SSD format for Ethereum 2 client. We can do that with this command. We want to name our node vol client 0. So let's create an environment variable for it. And lastly, we need to create keys for validators. Please note that if you're participating in DevNets, you will either get pre-generated keys or your validator will need to register your own keys. So let's copy command for generating the keys and key store. This will take a minute as it's a cryptographic command. Okay, so now the only thing that's left is to run our validators. Firstly, we should run Ethereum 1 validator. So let's go to Nevermind here. Here's Nevermind. And we want to use Docker. So we will use this command. Let me copy it. Few things to see here what we are doing here. We are starting Nethermind with JSON RPC on port 8545. We are using blockautor accounts 0x1 and zeros. And we are mapping some paths for the Nethermind client running from Docker that it would be able to access it. The most important one is the config file we pre-generated earlier. Okay, let's run it. Docker wasn't able to find Nethermind image because it wasn't installed yet, so it's downloading the Nethermind image. Okay, Docker run Nethermind image in the background. So now we will run teku from Docker. We scroll down here to teku docker. Here it is. I'll run this command. Let me copy it. Again, there's some JSON RPC on the port 5051. There's some mapping of paths. There's some metrics. For detail, I will send you to teku. It also needed to download the image. And now teku is started. As you see, Genesis time is 12:56:15 GMT, which is 2 minutes from now. So it's good that we specified this 10 minutes time. We want to see now Nethermind. So let me open a second session. Okay, I have a second session here. And let me attach to Nethermind's console from the Docker. Docker logs -f Nethermind. Okay, you see that we are getting some JSON RPC calls, but it's only each get blocked by number. So Ethereum 2 node is able to connect to Ethereum 1 node and ask for this. Now all that's left, we need to wait for Genesis time. This is still a minute ahead. So let's look at the time and let's look at what's going to happen at the Genesis. we can see that epoch event is happening on Teku sign. And the communication started. So Teku is now requesting Nethermind to create blocks, to progress its chain, and to set its head, as well as finalizing the blocks on Nevermind side if needed. So let's actually explore it a bit deeper. So we have a few things here. We have, let me check, consensus assemble block calls when the block is created. So this means that Teku is asking Nethermind to create a block and add some transactions to it. Then there is consensus new block when this block is being added to the chain. So if Teku decides that it wants to add this block to the chain that was created, it calls consensus new block. Then if it decides that this block would be the head of the chain, it is able to call consensus set head. And when some blocks are finalized, it can call consensus finalize blocks. That means that these blocks won't be ever changed again. And if they are on the main chain, they will remain on the main chain forever. Okay, as you can see, we are getting bigger and bigger block numbers. Now we are on 0xf, which is 15, and now it's 10, which is 16th block. So it's progressing well. And this is the end of the tutorial. Feel free to experiment now. You should be able to interact with both Ethereum 1 and Ethereum 2 clients in normal way. So for example, for Ethereum 1, that would be JSON RPC. You should be able to send messages there, like transactions. And if you send them, they should be included in the blocks. If you need, you can modify the generated Ethereum 1 Genesis file to give you some fonts for your accounts. That's completely okay. And as for endnotes, I want to thank everyone involved in this endeavor, especially people working on written tutorial and client implementations. If you want to take part in DevNets or you have more questions about the current state of the merge, I invite you to Ethereum R&D Discord server on the channel called Ryonism. If you have questions about Nevermind, then please go to Nevermind Discord server. Thank you for following this tutorial. May the Ether be with you.